This problem says, consider the function f of x below. At what values of x are the inflection points? If there are multiple answers, write them down separated by a comma. So we're going to be using the test for concavity to determine the inflection points, because inflection points occur when concavity changes. So we need to determine where is the curve concave up versus concave down. And that change is going to happen when the sign changes. So we're going from positive to negative, the concavity is going to change, and vice versa. So let's go ahead and take first the first derivative of x. So that's going to be minus 20 x to the fourth power minus 16x cubed plus 6. And then we'll go ahead and take the second derivative of that function, which is going to be minus 80x to the third power minus 16 times 3 is going to be 48x squared. And then the derivative of a constant is 0. And so this function will change, could potentially change values at the zeros of this function. So we've got negative 80x cubed minus 48x squared equals 0. I can factor out a minus 4x squared. I'm not sure I can factor out any other number out of that. So this is going to be 20x plus 12, and I guess I can factor out another 2, actually another 4. So minus 16x squared, and that leaves me with 5x, and this is a 3. Okay, so then I said minus 16x squared is equal to 0. So we'll use that as a critical value. And then we'll also set 5x plus 3 equal to 0. Okay, so we're nearing the final part of our work here, where we see that we have the interval from minus infinity to negative 3/5. And then we have another interval that goes from minus 3/5 to 0. We have an interval then that goes from 0 to infinity. And we'll go ahead and test a point from each of these. So let's go ahead and use -1 is in that interval. So it's minus 80, -1 to the third power, minus 48 times -1 to the second power. So this is going to be 80 minus 48, which is going to be 32, which is greater than 0. And we'll see if there's a concavity change. So why don't we try say a half. So -80 times a half to the third power minus 48 to the, and we want to do -1/2. Or -1/2 squared. And so then -1/2 to the third power is -1/8. -1/2 squared is a quarter. So we get 10 minus 48 divided by 4 is 12. So that's less than 0. So there is an inflection point at -3/5. Let's see if there's another change in concavity in the last interval. So we'll plug in a 1. And so we have -80 times 1 to the third power minus 48 times 1 squared. This is -80 minus 48, which is -128, which is still negative. Therefore, x equal -3/5 is the value of x at which there is an inflection point.